Hello everyone, and welcome to a new series where I'm going to be solving Advent of Code 2021 in C on my Linux machine. So yeah, we'll see. The first thing I'm going to do here is I'm going to show you which GCC I have. That's 11.1. So stuff I use might or might not be work on older versions. Anyways, so I'm gonna read this. You can skip ahead if you don't like the lore, but I think it's cute, so let's read it. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine the elves keep ready for situations like this. It's covered in Christmas lights, because of course it is, and it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. So obviously, this is the gamification of the whole thing. You have to get all the stars in order to finish the game successfully, right? Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. So basically each day gives you 2 stars. Good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby sea floor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the sea floor depth as the sweep looks further and further away from the submarine. So that's the basic story. This is day 1, by the way. I know it's already day 6, but I decided to do it now because I was too busy the past few days. This might be a recurring theme where I just do them in batches, but yeah. So our sample input looks like this. This report indicates that scanning outward from the submarine, the sonar sweep found depths of 199, 200, 208, 210, and so on. First order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. Do this, count the number of times the depth measurement increases from the previous measurement. So for example, 199 increases to 200, 200 increases to 208, but 210 decreases to 200, right? And so we can see this here. So there are several measurements that are larger than the previous measurement. How many measurements are larger than the previous measurement? So here, this would be 7, right? Because 1, 2, 3, 4, 5, 6, 7 are larger than the one before it, right? So this one is never larger than the one before, but yeah. Okay, so what we're gonna do is I already put the sample input into a little folder here. I already did started doing it, and then I was like, you know, I should record this. So this first one is pretty straightforward. We're gonna start with a little main.c file. I'm gonna quickly show you the input. The text is the actual input down here that you get when you log in. And the sample is the sample data that we have here that should return 7 when our program works properly. So each of these Advent of Code problems have a few issues. The first one is you have to read a file, right, every single time. So we're gonna build a little support library for this. So we're gonna do mkdir common, and so we're gonna do a little fileops.h, and this is just gonna be a little bit of a support library. Let's see. So we want to be able to read a whole file basically into a buffer that's malloc allocated, right? Allocates a buffer, reads the file into it. Buffer has to be free at the end. Okay. So in this first challenge, we probably won't need this, but we'll write it anyways, and we'll see if we need it. I'm not sure. We could do it probably with fscanf, even though that's really scummy. We'll see how we solve it. So let me quickly check. Can I check how long I've been recording somewhere? I can, 4 minutes. Okay, that's pretty good. So all this is gonna do is we need standard int. We need oh, the rest we'll see. We'll figure it out. Okay. So we'll have a uint8t read file, and we're gonna have a const char file name, and that's pretty much gonna be our interface. And also we're gonna have a size t size. Okay, that's pretty much it. And size t is in standard def, I think. Right, of course it is. By the way, if you're wondering which editor this is Neilvim, but you can use whatever you like. I might switch it up between episodes as well as I get tired of one or whatnot. Okay, and then we'll do common impl. We'll do. So this is a pattern where you put the implementation in the same file as the definition. We'll see how that goes. Yeah, we'll see. As I said, we'll see. This way you can include it in multiple files, but only define it in one kind of thing. So we'll see. So we'll implement this. It's going to be pretty straightforward. We're gonna need standard IO, standard lib, since we're allocating. Yeah. Okay. So cool. Now let's see if we can read the file. So we wanted to figure out first the size of the file. So for that we need systat. This might be in different places on different systems. I don't know where it is on other systems. I'm gonna assume everything's on Linux. By the way, the font is IBM Plex, in case you're wondering. Okay. So first you want to make a struct stat. That's our file stat. Okay, and what this is going to do is this is going to be the target for our stat, right? So we want to stat the file name, and if that's not null, not 0, then something failed, and we want to just error stat and return null. Okay, all right. So next part is the file size, right? The file size is stored in this file stat as st size, right? So that's in bytes. And then we want to just go ahead and allocate that file size, right? So here we're allocating our buffer. Now this isn't perfectly, like this isn't perfect. The file might change between this line and the line that we read, or this line and the line that we actually read the file, but I'm going to assume this file is static. Like this isn't a proper library grade implementation, right? The proper library grade implementation would be to read from the file until you reach the end of the file, or you can't read anymore, or something like that. Like basically you want to read from the file until read fails, but I don't like doing that. So I'm just going to do this. All right, so this is our buffer. And our buffer is going to be uint8t malloc file size. This is pretty expressive, I think, and if that fails, obviously, then something went horribly wrong and we ran out of memory, but we're just going to be like error malloc, which basically just prints the error we want to return null in this case as well. Okay, so now we get into the zone where we actually want to open the file. Right, so the file is going to be a file pointer, file open. We're going to do the file name here, and we want to read the file. All right, so if that fails, we want to pr open, and we want to return null again. But since we're going to leak memory here, and I'm sure this will tell us, no, it won't. We basically want to free the buffer as well, since at this point we would be leaking memory, right? Like we're gonna free at the end. Like we're gonna free at the end of the function before we return, or actually we're never gonna free the buffer in this case, right? In this case we're gonna return the buffer, of course, because that's our target, right? Our result, if you will. So what actually happens is the buffer, because we're returning null, since we had an error, is actually going to stay unreachable but allocated. And in this case with leak memory, doesn't really matter, but if I'm going to do this, I might as well do it right. Okay, so now comes the easy part. Size t bytes read is read file. Let's see if I can do this. Buffer and obviously the file size. Okay, and so this is going to read all the bytes that we want. Now, if bytes read, like bytes read, is not the same as the file size, something went wrong in our read. We want to the error read. We want to free the buffer. Actually, we can close the file right here because no matter if it was an error or not, at this point we don't need the file anymore. So we want to free the buffer. Very cool. And return null, of course, right? Oh, shit. Didn't mean to do that. Okay, cool. So in this case, we're going to have read the entire buffer into a file. This is pretty complicated in C, so I wanted to make it a function and not write this out every time and then forget what it does. So, yeah, okay, that should do it. Oh, actually, no, the out size, right? So the out size becomes a file size, right? So here, we guarantee that out size is going to be defined at the end, right? So out size is 0, so we initialize it to 0. At this point, we initialize out size to file size. And the reason we initialize it to 0 is because even if we return null, we want you to be able to access out size and the values still to make sense, right? If you pass in an uninitialized out size and it won't be initialized in here and we return right here, then we never get here, never get to initialize. It stays uninitialized. You might use it. I don't know. I don't know why you would. And even if all this fails, you still have the file size, which I guess it's completely useless. Yeah, that's completely useless. I just don't want to leave it uninitialized. It's just horrible. I mean, you know, that technically you want to initialize this as well, but it can't, like, this is gonna happen, so it doesn't matter. All right, now that we have file ups, let's, like, I have these little shortcuts here. GA is git add, GC is git commit. I'm gonna read these out as I type them. So we want to git add the common folder, git status. Okay, now we want to commit that, git commit, and the change is add file ops with file open. A file was read file helper. Okay, so now let's go back into 0.1. Actually, should we write a make file or something? Let's write a cmake. You know, just cmake lists. Let's write a cmake lists. AOC 2021. Cmake minimum required version 3.15. I don't care. It doesn't matter. You can change this if it doesn't work for you. Okay, and then we're gonna do add executable, and that's gonna be p01 01 main.c. Okay, and we're gonna actually, for now this is okay. I think for now this is okay. Technically you want each one to have their own cmake lists, but let's not bother with this. We want to include directories. I'm just going to do this very crudely common. Okay, cool. Now we're gonna cmake this directory with the binary directory bin and the generator ninja because I want that, but it doesn't really matter. Okay, the main.c isn't found, so let's actually make that. We touch it, create the file, and there we go. And now if we go into here, actually we don't even have to go in there. Well, we should. Let's do that. We can now do ninja c bin bin p01, and that's going to run our file. Now, obviously, this doesn't work because we don't have a main function yet. So let's define a main function. Okay, so int main, we want to provide that it's void so that it doesn't like fuck with us. And I guess the first thing we want to do is we want to read the entire file, right? I think that's what we want to do. So since we've already made this, let's do it and include what is that called? File ops h. And in order for my new vim to actually find this, editor to find this, I have to do one more thing. That's a little bit embarrassing. Sorry about that. Was it export compile commands? Right. I have to actually use my mouse here. Compile commands on. Okay, we copy bin compile commands here, and then we're gonna edit this file. All right. Okay. Found not found. Very strange. Could have bet we called it fileops.h. We did call it fileops.h. Why isn't it working? This is horrible. Let me figure this out and I'll be right back. Right, turns out my editor was just being confused, so we're just gonna use a different one until I figure that one out. So we have our fileops.h here, which we properly have imported here, and since it's gonna be the only place where we're including it, we also need to define this. What this is gonna do is it's gonna enable it to actually implement this, right? Okay, so we want to read the whole buffer, right? So int8t buffer is gonna be read file, and this is gonna be 01 sample.txt. All right. And let's make sure we're actually in that directory when we run it. We're not. Okay, let's just double check, make sure that's working. Okay, cool. So we want to read the file, and the size, buffer size is 0. We're gonna pass it in. Okay, there we go. And this reads the entire file into a buffer. If buffer is null, we want to return. Okay, so now we could actually print out that. So read a buffer, read the file lu bytes. We're gonna do that really quick so that we have a little bit of an idea here. So 01, so actually this doesn't matter. I don't care about the file. I know which file I'm reading. Read how many bytes, that's gonna be buffer size. Okay, let's run this. Ooh, too many arguments, too few arguments to fread. Oh, of course it wants uint8. See. It wants to read now the file, the size of each character. Then, wait, no, it wants the buffer, then the size of each character, and then the size of the file or something like that. We'll see. And it crashed. Okay, I don't know how that works. Let's see. How does fread work? Did I am confused? Pointer. Oh, yeah, of course, I'm sorry. So this is the buffer, and then this is a strange interface. Buffer, and then the size of each one, and then the size of the file, right? Yeah, and then the stream, yeah, strange, okay. Also, let's disable this. Okay. Let's turn this off. Who knows what this is? Okay. So read 40 bytes, and that seems to be accurate because the entire thing is 40 bytes. So let's run this again. There we go. Can we run this like that? Okay, it says read 40 bytes. Very cool. Very cool. So now that we have a basic build system set up, we can actually solve the first one. The first one is just going through and reading all these values and figuring out if this one changed in relation to the last one, right? So what we want is we want to find, yeah, so there's this thing called A to I or something, right? I want to figure out how this works. So discards any white space character until the first non-white space, then takes as many characters as possible to form a valid integer number representation, right? So I know this one is sort of shit. It's pretty garbage, honestly. We could use str2l. I think that's better, right? Yeah, it gives us back the, yeah, okay, this is better. So string to long gives us the long. That works. Unsigned. Pretty good, all right. So we want to get the start of the file, right? So this is our iterator. That's going to be at the buffer, which is our beginning, right? And then while, and the end, of course. The t pointer end is buffer plus buffer size. Okay, so while we're not at the end, where the end is not, like, it's plus the buffer size, so it's one off of the end, so it's like it's one over the end basically. So we want to have a less than here. In this case, we want to do str2l. So this takes this string, then the end. Oh, it's going to give us back the end. That's very convenient actually. So we want the end, and then the base, which is base 10 in this case. All right, and this one's char pointers. Very cringe. So I guess we'll use char pointers here. That's very, very cringe, but okay. And we also want to not miss to free the buffer at the end, just to make the gods happy, you know. So what is this? Unsigned long. Okay. Let's say u in 64t, I want to say. Never read. Yeah, that's okay. Okay, so I just wanted to make sure that this is the same thing. I could just look this up. Yeah, it's unsigned long. Okay. So basically we want to have the previous value and this value. So u in 64 t previous is 0. Okay, so I guess the previous doesn't matter. So I guess we can just read the previous right away. So we want to set iter's end, right? And then we want to do that. So the reason we do this is because we want to then figure out whether it's bigger or smaller than the previous one, right? So we can always assume we have more than one because the first one doesn't matter, right? So this is just like this is a very specific solution to a very specific problem, and this is not a universal like solution, right? Oh God, we're already at 25 minutes. Well, that's life. Right, and so let's see. So if previous is less than value, or let's be clear here, if value is bigger than previous, which is actually what we want to check, then we want to larger values, or larger count 0. We want to increment larger count, all right? And then at the end, we just want to be like solution LU larger count. Okay, let's see if this works. So this says solution is 9. Let's check if that's correct. The solution was supposed to be 7. All right. So, oh, of course, because I don't assign previous. Right, okay. Cringe. So that is 7. Okay, so now it's correct. So the solution is now 7, and that is exactly what it's supposed to be. All right, cool. Very, very cool. Can we like... Let's do that. Does that like automatically output it now? Cool. Okay. Solution is 7. All right. So exactly what we want. And now we just need to change this to input the text. Get our value. So value here is 1139. Let's see if that's correct. Hey, that's correct. Sweet. Okay. So that is the first coding challenge of AOC 2021 solved. We're gonna actually, let's quickly commit this change, which fix invocation. Is that how you spell invocation? I don't know. Invocation of read. Okay, so now we want to add GA01 here. And we also want to add CMake lists. All right, so solve first per day, add CMake lists. All right. Now we also want to change the README to say to run first execute CMake. And then how does it work? CMake build. Is that how that works? Let's see if that's how that works. I want to just give like a... Yeah, that's how it works. Okay. I'm just writing this out to make sure that like it's beginner friendly, you know? I feel like that's a cool thing to do. I want to push all these. All right, and as you can see already, remote origin get URL. Can we do that? It's gitlab.com/linecore. Actually show this right here, /AOC 2021. And right here you can see all the steps I just wrote out. You can see the solution to the problem right in here, for example. Wow, GitLab is being slow today. Okay, here you see the solution, and yeah, that resolves the first day. If you enjoyed it, please make sure to leave a like and subscribe if you want to see more. And I will see you on the next one.